activation functions. Now let's move towards the final CNN fundamental tutorials tutorial collab. I'll just open it in collab. So in this cell I show the collab badge, which is mainly used to open the notebook directly that we have opened. And now here I am introducing the topic of convolution neural network. I explained this that CNNs are widely used in computer vision tasks such as image classification. I also mentioned how CNN evolved from to early stage architectures like LeNet to modern models, and this gives a context about their importance. So this cell sets the foundation for the entire notebook. Now in this cell I import all the required libraries. I use PyTorch for building neural network, NumPy for numerical operations. I also imported dataset utilities and transformations, and then I set random seed um, to ensure the reproducibility, and finally I adjust plot settings so that the output are clear and easy to read. Now I'm explaining why CNNs are needed. Fully connected networks flatten images, which removes spatial relationship between the pixels. They also require huge number of parameters. CNN solve this using local connectivity and parameter sharing. This makes them more efficient. So this will explains the motivation behind CNN. Now in this cell I'll explain how images are represented in a grayscale image is a 2D matrix, while color image is a 3D tensor with RGB channels. Each channel contains pixel intensity values. CNN directly operates on this structure and helps preserve spatial information. So the understanding is important before applying convolution. So here we are understanding the convolution, and then once that is done, I'll introduce convolution, and a small filter and kernel we will create across the image. At its position, element wise multiplication is performed and summed. This produces one value in the output feature map, and repeating generates the full feature map. Different kind kernels detect different features like edges. So let's go towards this. So here we have introduced kernels and kernels of filters, and these are the famous kernels used, and we can see what different kernel detect different features or edges like textures. So this is what this output is showing. um, So earlier in this cell I am visualizing the convolution process. I show how kernel moves across different part of images. Each step highlights the region being processed. The output is built gradually. This makes the idea of local feature extraction clear. It helps connect theory with visual intuitions. And in this next cell I'll explain the pride and stride part. So I explained stride and padding. Stride controls how far the stride explains how far we can go, and just a second. So pride and stride visualized. So I explained the stride and padding. Stride controls how far the kernel moves at each speed, and larger stride reduces the output size. The padding zeros border. This helps preserve spatial dimension and include edge information. These parameters directly affect the output shape. In this cell, I experiment with stride and padding, applying different values and observe the output size. So I have given different stride and padding values, and I will observe the output sizes. When stride increases, the output becomes smaller, and when padding is added, the output size can be preserved. So if you can see here, so our initial size was 32, we added the stride, it came to 30, then we added the pride, so it preserved the older state. When we increase the stride again while padding remaining same, it again got decreased, and when we increase the padding again, the output size remains the same. So we can see how it works. And in this cell, I'll introduce multiple filters. So instead of using single kernel, CNN may use many filters in one layer. Each filter learns different features. This results in multiple feature map. Together they capture richer information for the image. This increases the model representation power, and that's what we are doing. Now in this cell I apply multiple feature filters to the same input. Each filter produces their own map, and map stacked together as channels. This forms output convolution layer, and it shows CNN built with in features as layers increases. So that's what we are seeing here in the output. Now here I'll introduce activation functions.